All right. Hello, everyone. You'll notice that down below there are Spanish subtitles. So if you need to use them, please read the Spanish subtitles. So today we are going to be talking about experimental design, how we, the scientists, design an experiment. As SpongeBob says, experimental design. I'm going to read this to you. Feel free to read along in Spanish. Also, you can read the subtitles as well. All right, so this is an example of the scientific method in real life. Dominic loves plants, but has a hard time keeping them alive. His grandma tells him it's because he isn't watering them enough, but he disagrees. Dominic thinks that if he waters the basil plants more, then they won't grow any taller. To prove his grandma wrong, Dominic decides to test it out. He plants 4 basil plants. He uses the same potting soil for each plant and places them all in the same window so they get the same amount of sunlight. Every day, Dominic waters each basil plant. One plant gets no water, one plant gets half a cup of water, and one plant gets 2 cups of water. Each day, Dominic also measures how tall each plant is. So this is an example of the scientific method in real life. And we're going to go through this experiment and kind of line it up with the vocabulary words that we're going to be learning today. So the scientific method is how we, the scientists, figure stuff out. So at the beginning of every experiment, there's a purpose or a question. So for Dominic, he was like, why aren't my basil plants growing? That was his question. Research. So you should look up stuff about your topic. For Dominic, he asked his grandma. He also, used what he already kind of knew about the basil. He had looked at his basil plants before. And we'll get into hypothesis, experiment, analysis, and conclusion in a second. But remember, the question or the purpose is always when they go, what do I want to learn? So for Dominic, why aren't my basil plants growing? All right, so a hypothesis is what we think will happen during an experiment. And it's always written in this format. If the scientists make this change, then what we measure will change. So for Dominic, he said, if we increase the amount of water, then he said his basil plants won't grow more. All right, so one more time. For Dominic, his hypothesis was if we increase the amount of water, then my basil plants won't grow. That was his hypothesis. In every experiment, there's going to be 2 different variables. We have the independent variable and the dependent variable. For the independent variable, I will call this the IV. And for the dependent variable, you'll see it called DV. The IV is what the scientists change throughout the experiment. The DV is going to be what the scientists measure, and it's going to change because of the IV. So the dependent variable changes because of the independent variable. So for example, in Dominic's experiment, he changed the amount of water each plant received. He measured how tall his basil plants grew to. So he measured plant growth. And the plant is going to grow based on how much water it gets. So it's dependent upon the independent variable. The format for a hypothesis is listed below. Remember, if what the scientists change, then what the scientists measure. I want you to try to do this in either on your head, feel free to write it in the comments, feel free to write it on a piece of paper. So in the blanks, I want you to take a second and write if IV, if independent variable or dependent variable, then IV or DV. So you're figuring out where the IV and DV go into our hypothesis. So remember, for the hypothesis, it's always if the scientists make this change, then what we measure will change. Take a second. So hopefully you wrote if independent variable, or you could have just put IV, then dependent. So how did I get there? Or you could have written DV here. So remember, our format for a hypothesis is if what the scientist changes, then what we measure will change. So remember, what the scientist changes, that's called the independent variable. What the scientist measures that's going to change as a result of the IV is the dependent variable. So for a hypothesis, it always goes if IV, then DV. Or if independent variable, then dependent variable. There's also these things called experimental groups. These are the groups that are changed during the experiment. So, for example, with Dominic's experiment, the first group got 1 cup of water. The second, or got a half cup of water, I'm sorry. Group 2 got 1 cup of water, and group 3 got 2 cups of water. Those are the experimental groups. We have group 1, group 2, and group 3. Half, 1 cup, 2 cups. Those are the experimental groups. The control group is the group that doesn't change during the experiment. And it's used to see if the independent variable is actually causing the dependent variable to change. So for Dominic's experiment, there was 1 plant that got no water. That's his control group. So for this, we know that if plants don't get water, they won't grow. But who's to say, if you're doing an experiment, who's to say that the IV is actually causing the DV to change? That's why we need a control group. All right, I want you to answer this in the comments. All right, you just have to put 1, 2, or 3. Talia wants to know how fertilizer affects plant growth. She designs an experiment where plants receive different amounts of fertilizer. 3 of the plants receive fertilizer, but 1 doesn't. Which of the following is the control group? Is it 1, the plants receiving fertilizer, 2, the plants, 3, plant growth, or 4, the plant that doesn't get any fertilizer? So you are answering this in the comments. So hopefully you said number 4. Remember, the control group does not get what the scientist changes. So the control group here is the plant that gets no fertilizer. That is our control group. All right, so I want you guys to do some experimental design practice on your own on Google Classroom. I'm going to give you all today and tomorrow. All right, so today I'm going to post a review of what this video is about. Feel free to watch this video as many times as you would like. All right, you can watch this video over and over again. And there's a Google document on our Google Classroom that you need to fill in. Tomorrow, I'm going to have you guys do some more experimental design practice. If you need help, I have office hours every day from 2 to 2:20. If you're interested, email me. All right. Bye, everyone. Have a good rest of your day.